Hi, everybody, and welcome to Astronomy on Tap. We are continuing today with our Astronomy on Chat interview series. This week's guest is Tobias Beuchert. We will be discussing issues pertaining to astronomy and climate change. Tobias is a presenter at the European Southern Observatory's Supernova Planetarium and Visitor Center in Garching, Germany. Previously, he was a postdoctoral scholar at the University of Amsterdam, and he received his PhD from the University of Erlangen-Nuremberg in 2017, where he specialized in studying active galactic nuclei. Tobias has an extensive background in science outreach and communication, and also likes to focus on climate and environmental issues as a large part of his job. He is also a member of the Astronomers for Planet Earth Network. This is a volunteer network of astronomers and astronomy educators that share the common goal of sharing their astronomical perspective about Earth and climate change with the public. Astronomy on Tap Budapest listeners may also be interested to know that Tobias is half Hungarian and his mother grew up right here in Budapest. So Tobias, thank you very much for chatting with Astronomy on Tap.
Hi, thanks for inviting me.
Yeah, I'm glad to have you.
So great to be here.
Yeah, so to get started, can you tell me a little bit about the seriousness of anthropogenic or human-caused climate change?
Well, it's damn serious, I would say.
Yeah.
And I think as an astronomer, I think the most important point is timescales. So timescales kind of tend to tell their own story, and what I always tell the public during planetarium shows is just to imagine Earth being, Earth 4.5 billion years old, just imagine that happened in 1 year. Then we can see how long do humans live on the planet. Let's say Holocene and after 10,000 years, that would be 1 hour of that year, wow. Right? And then I'm thinking, within less than 1 second, we managed to impose exponential growth onto our planet. Different parameters and so on, many of them affect climate change nowadays. And what exponential means, we realize during present times, Corona and stuff. Mm-hmm. So it's not necessarily something we understand, I would say. And this is where astronomy comes in, I think, which is really important because we deal with timescales and different exponential growth and so on all the time. And I think Earth has never experienced such a dramatic change in a short time scale before. And Earth wasn't always as it is. Earth wasn't always habitable, but I would say now there's a species, humans, that enforced an uninhabitable world with full awareness. And that's something that makes me think quite a lot. And then, of course, why is it serious? Because it has effects on the future, right? We expect climate refugees, hundreds of millions of them, according to the UN. We have sea level rise, extreme weather conditions, and so on. That's, and climate is a fragile system. Earth is a fragile system. So we have to deal with it and find solutions.
Yeah. So what are some of the primary measures or statistics that we use to gauge the impact of climate change?
Right. So I think paleo archives is one of the words here. So we have to dig into the history of our planet Earth. So we have to understand how was the climate actually evolving. And as I said, it hasn't always been that nice. It just turned out to be really nice during the past 10,000 years or so. But now we seem to destroy that pretty quickly, and it's quite stupid to do that actually. And how do we measure the climate in the past? We have to understand what is actually the impact of humans. We have to measure the temperature, for example, and that we can do, for example, with by measuring oxygen isotopes. So there are heavy isotopes and less heavy isotopes. And if we measure the
So
ratio of those.
just so an oxygen isotope, that's like when you have an oxygen atom, but it's like has more or less neutrons in it, right?
Yeah, exactly. And there's one which has 18 neutrons, so it's heavier. And the heavier oxygen is, for example, not that abundant in gas in the atmosphere. And that's and if you have a hotter climate, you have more water vapor, for example, so you have more of the lighter oxygen in the air, and this is stored in different in the earth, in the oceans, in ice cores, and so on. So you can measure the temperature over the past. And if we look at the past 800,000 years approximately, there was a periodic change of warm and colder periods. It's called the interglacial times, and there were ice ages and warmer periods, and now we tend to be in a warmer period. But what's important to say is if we measure the temperature over the past, and we can measure the temperature even further back in time, over the past 800,000 years, the temperature now is much higher than expected from any natural mechanism, the temperature over the past years now. Combined with that, CO2, carbon dioxide, is a really important driver because we have the greenhouse effect. CO2 is one of the most important greenhouse gases. And one has to say the temperature variations over the past were driven by astronomical influences, externally induced by changes of the Earth orbit around the sun, by the Earth tilt, the axis, the tilt of the Earth axis, and so on. That was driving the temperature changes, and probably, maybe also the CO2 changes that went along with the temperature changes. Today, CO2 went up dramatically. The CO2 level today is higher than, I mean, any time before, any time for the, I mean, higher than over the past 800,000 years. The concentration in the atmosphere, and that is now leading the temperature. So now the temperature follows the CO2, more greenhouse effect, and therefore higher temperatures. And that has also been unprecedented over the past 800,000 years, which is definitely human-made, and there's no doubt. So I think it's scientifically waterproof, and that's also something that I think everyone accepts, most of us. And now we have to work on, on using statistics and using the knowledge we gained to find solutions for the future.
Yeah. So you mentioned carbon dioxide. Right. And so one term that people may hear about a lot is a carbon budget. Is that related to carbon dioxide, or what exactly is meant by that?
Yeah, it's basically the amount of carbon dioxide we're still allowed to emit in the future in order to reach the climate, the goal of 1.5 to 2 degrees Celsius extra warming compared to the pre-industrial times. And I think we emit about 40 gigatons of CO2 per year right now. And it would mean that we would have to go down. So I have a curve here. By 2035, 2040, we have to be at zero emission in order to fulfill the climate, the goals of 1.5 to 2 degrees Celsius extra warming. Yeah. So there is a maximum amount we're still allowed to emit, basically.
Okay.
Yeah.
So since this is a astronomy on tap interview, so what is the biggest impact on the climate that is actually caused by astronomy and astronomers?
Right, I think that's a fair point to raise, and that's also something we as astronomers are dealing with a lot, and thanks to you, we're also talking about it in the public. We have been traveling a lot, and I think during times of Corona, we learned dramatically well how remote conferencing can be possible. Before, there was always the arguing, well, but we have to do networking, we have to meet ourselves. Yes, there's a point to it. We need to do that, but we also have to be reasonable in some sense. And I think flights, travel is one of the biggest impacts of astronomers, where researchers, like other researchers as well, I mean, biologists, chemists, ecologists, they all operate in an international network, and there are conferences visited by international audiences, so you have to find venues. But now many conferences actually happened. They could be realized within a couple of months. Online conferences were set up. So this is, I think, where the future is leading us to. And of course, me working at the European Southern Observatory, we do also operate big telescopes. They also emit CO2 in the end. The new telescope, the extremely large telescope, will also operate with solar panels. I'm not really an expert on the details. That's something one can read online, but there has been a strong focus on reducing the CO2 emissions also as an international observatory.
So that extremely large telescope, that's still in development, correct?
That's still in development, okay. Yeah. It's being built right now, and yeah. So this is, I think that, yeah, and then we use electricity, service, computational centers. Yeah, definitely, and we do communicate about that in different communities within astronomy to find ways to reduce our own budget, because of course I can't talk about climate change and the impacts if we don't actually, pay attention on our own CO2 budget and footprint. So that's the first thing where we have to start with, I would say. Yeah.
So how specifically does the climate crisis impact astronomers' ability to carry out their research, maybe going into the future?
Right. I mean, one thing that comes to my mind, of course, having worked at the University of Amsterdam for 2 years, is sea level rise. I mean, we expect, in the worst case, I would say 1 meter of sea level rise, the 21st century towards the end. And that would be, basically the end for a large part of the Netherlands. And the Netherlands is a big hub internationally of astrophysical research. So life will be difficult, as it is difficult today during Corona. So there will be impacts. And I think a quite important issue, besides the question, can we still operate our telescopes within changed climatic circumstances, is the social factor. So we depend on the public recognition that fundamental research is still important. Also during challenging times. And I feel privileged to be an astronomer, to be able to do research, but it should not be a privilege for humankind to conduct research. It's just something that we have to do. We have to find for answers. We have to understand, by doing research, we understand the next steps. Without research, we wouldn't know where to go. What can we do? So global crises can compromise astronomical and fundamental research, and especially in underprivileged areas, I would say. So we have to be really careful not to forget also this point. How are we affected? We can go even further and say, as I said, climatic changes, the weather will change. We have more extreme weather conditions. How does that affect astronomical observatories? We
hard
have
to see
rethink
the stars on a cloudy night.
Yeah. For example, yeah. So that's but I think doing research as a global citizen, that's just something we have to be able to do in the future as well, despite global challenges. And we all know that we will live through a transformation in the future. It's starting right now, I would say. Yeah.
So you mentioned how flights have a big impact on this, and that's one of the things that the biggest impact that astronomers have on climate change. So what can astronomers really do to get rid of that? You mentioned virtual conferences, which we're realizing now is like that's something that like needs to become like the norm in the future.
I would say not the norm, but an option at least, because I do see that young researchers need to do networking, and there has been a lot of discussions right now among researchers how you can really optimize that for the future. Building hubs in big cities where you meet as a local community and then you connect online to other hubs. Danger is, of course, that networking is only possible within your hub. But I think we have to see it as an option. For example, I don't have to fly to Taiwan to give a 2-hour talk and fly back the next day. I can do that remotely. And this option has to be there. So again, being reasonable, knowing the options, finding solutions, and then I think we can reduce emissions dramatically.
So switching gears a little bit to wrap up, I wanted to ask you some more about your background. So you changed from doing more scientific research to doing more public outreach.
Right.
What was the primary motivating factor behind this change?
One of the main drivers was, I think, that I felt the gap between the public and me as a researcher or research in general was bigger and bigger the deeper I was diving into research. So there was a lack of trust, I think. You always had, I mean, and I think it's a quite meaningful job to build bridges to the public, because it is our responsibility, I think, as researchers not to be too detached from the public, because we act as a planet. We know there is no planet B, so we have to communicate a lot. Communication is a key thing, and it's lacking in research environments sometimes, and especially to the public. That's just how do you explain difficult issues with the public? How do you discuss that? So building trust, doing an empathic communication, that was something I always wanted to do, something that I was trying to do also, and now I'm happy to do that as a job. Also, I mean, my job as a presenter at ESO is 70%. During my 30%, I will developing a freelancing activity now to dive more into climate and environmental communication. And I think, if I may say one word about the intrinsic motivation I feel behind that. So I think it's important. Astronomers have the ability to step back to the so-called Earth rise effect. We have a unique perspective on Earth. We're observing the universe from a tiny blue dot in space, and we're about to have a pretty good understanding of the universe. And all that is happening on this tiny pale blue dot, as it's called. There was also an initiative by the IAU, International Astronomical Union, on the pale blue dot. So it's a thing, and we can shed a different light to that topic, talking about awareness and so on. And as I said, there is no planet B. We need a fundamental rethinking of how we're continuing life on Earth, and I think astronomy has a good access point to discussing that question. Also because we have a lot of parallels. The research we do has many parallels to atmospheric research on Earth, planetary research compared to geophysics, for example. There are just many parallels where we can support our fellow colleagues from disciplines like geophysics, environmental studies, climatology, and so on.
All right. Well, thank you very much for sitting down with us today and talking about this very important issue.
Yeah,
Really appreciate it. And
köszönöm szépen.
köszi szépen. Viszontlátásra.
Viszlát.
So yeah, thank you very much, and hopefully we can have you on again sometime in the future.
Yeah, thank you very much. And yeah, have a nice evening.
Okay, yeah, you too.
Or day.
Bye.
Bye-bye.
Thank you, everybody, for tuning in to this week's Astronomy on Chat interview series. If you would like to learn more about Astronomers for Planet Earth, the ESO Supernova Planetarium, or the kind of outreach activities that it is that Tobias does, then check out the links in the video description below. Thanks, and see you next week.